In this module, you will learn about Kepler's second and third laws of planetary motion. Kepler's second law of planetary motion, also known as the law of areas, states that the line joining the planet to the Sun sweeps out equal areas in equal intervals of time as the planet travels in its orbit. Let's explain this through an example of Earth's movements. Suppose the Earth takes 1 month, that is 30 days, to travel from point P to Q on its orbit. Imaginary lines drawn from the Sun to points P and Q, together with the Earth's orbit, enclose a roughly triangular area. This area is equal to the area covered for any 30-day duration during the year, regardless of the Earth's position in its orbit. Thus, as shown, area A1 equals area A2. Further, according to Kepler, the speeds of planets in their orbits vary through the revolution around the Sun. When planets get closer to the Sun, they move faster. Conversely, as they get further from the Sun, they move with relatively lower speeds. Therefore, the speed of a planet is highest at perihelion and slowest at aphelion. Kepler's third law, the law of periods, defines the relationship between the orbital period of a planet and the average radius of its orbit. The orbital period of a planet, denoted by T, is the time taken by the planet to make a complete revolution around the Sun along its orbit. The average radius of the orbit of a planet is also the mean distance of the planet from the Sun. For example, suppose R1, R2, and so on are the distances of Earth from the Sun for n number of positions of Earth in its orbit. Then, the average radius of Earth's orbit can be calculated as shown. The law of periods states that the square of orbital period T of a planet is proportional to the cube of its mean distance r from the Sun. Hence, you can express the law of periods as T square is proportional to r cube, where T is the orbital period of the planet in Earth years, which is approximately 365 days, and r is the mean distance in astronomical units. Astronomical unit AU is the mean distance between the Earth and the Sun. Thus, an astronomical unit is approximately 93 million miles or 150 million kilometers. If we consider 2 planets, A and B, and compare their mean distances from the Sun and orbital periods, we get the relationship as TA square divided by TB square is equal to RA cube divided by RB cube, where TA is equal to orbital period of planet A. TB is equal to orbital period of planet B. RA is equal to mean distance of planet A from the Sun. And RB is equal to mean distance of planet B from the Sun. Scientists use Kepler's laws to determine the positions and the orbital periods of various planets in the solar system. These laws also help us in calculations involved in determining orbital periods of satellites, natural as well as artificial.